using the graph to the left, when x is equal to 0, what is y? In this case, y is 4. When y is negative 2, what is x? Well, now, when y is negative 2, x is negative 6. So you go backwards. And then when x is 2, what is y? Y is 2. Find the distance between the points on the graph. So find the distance between the points on the graph. Oh wait, that's my other side, sorry. Use the function below. What is f of 5? 5 represents x. That is 1. What is f of 2? That is 6. And then solve. If you solve this for x, your final answer was negative 6. And I need to see the work for which one are you hesitating on?
I just missed what you said for the second one, the f of 5.
Yep. So f of x is equal to y. It's kind of like the generic notation. So anything in the parentheses represents your x value. So then the ordered pairs are always considered an xy. Yep. So then that's your x, and then your answer is the y. You're welcome. Yeah, that's like just kind of one of those weird notation rules. So I like to review. All right, and then what is the equation of the slope? So again, to write the equation of the line in slope-intercept form, you would just take the y-intercept and then account for your slope. In this case, the slopes are positive and they are 1, like not quite 1-to-1. So you would want to start with your y-intercept at 0, -1, and then you want to look for the next point. It goes directly through a corner. So it goes directly through this corner here and that corner there. So that's going up 3 and over 4. So my equation is going to be 3/4 x and then my y-intercept of -1. So then I kind of like this matching one for 1, 2, 3, and 4. So you had to decide, okay, what matches with what? Well, the easiest is that 1 matches to C because the square root of -1 is always I. So then I squared would be like the square root of -1 squared. And that's why I squared is equal to -1. Because the square and the square root cancel each other. So it goes CD, and then I cubed is the square root of -1 times I. So that's A, and then B. And then here, you had to distribute your -2 to get -14, positive 12i, combine like terms. You should always simplify in the form a plus bi, where it's the real plus the imaginary. That's called standard form of a complex. So 14 minus 4 is -10, and -9i plus 12i was 3i. And then the last two, oh, I'm losing my voice. The last two, you wanted to do quadratic formula for. And our final answers. And there's yesterday's, so it's no big deal. Here are your final answers. And again, if you didn't get those, I'm glad to show you all the work to get there. So quadratic formula, quadratics, they were a huge part of Algebra 2. They're going to continue to be a huge part of your mathematics career. It doesn't go away. It pops up a ton in pre-calc as well as in calc. So I can promise you need to know quadratic formula for your final. Are we okay with 1 and 2 and 1 and 2? Are we going to see any of those work out? Are we capable of simplifying anything that needs simplified? So like number 2, it would have all divided by 2.
So whenever it was like -8 plus or minus 2i,
Yeah.
I was wondering if you ever -2.
They just divided everything by 2.
Okay, so like the negative on the bottom isn't divided, it's positive.
So, right. So a negative divided by a negative becomes a positive. And then here, because of the plus or minus, they both still, like, a plus divided by a negative would stay negative, a negative by a negative would stay positive. So the plus or minus here doesn't get affected by that negative. Just the beginning part, which would be your axis of symmetry on the vertex. So if you think about it, like this negative is going to reflect it. So that 8, instead of shifting to the right, is shifting to the left or vice versa. Axis of symmetry will be back tomorrow. Alright, so what I want to do is review chapter 3 with you today. So let's